So if you've ever touched data in Python, you already know it's incredibly versatile. But what if I told you there's a library out there that turns Python into an absolute numerical powerhouse? Well, today we're doing just that. We're unlocking the power of Python with NumPy. Okay, so here's our game plan. First, we're going to tackle why we even need something like NumPy. That's the need for speed. Then we'll properly introduce NumPy itself. After that, we'll dive into its secret weapon, the array, and see all the superpowered math it can do. And finally, we'll connect all the dots and see why it's the absolute foundation of data science. All right, let's set the scene. We're starting with a common problem, a real bottleneck that pretty much anyone who works with data in Python has run into. You know that feeling, right? You try to run a calculation on a huge list of numbers in Python and you just wait, staring at the screen, wondering if it's ever going to finish. Well, you're definitely not alone. The big question is, why? Why can it be so slow? This slide really just nails the core difference. With standard Python, you're processing numbers one at a time, in a loop. It's kind of like a cashier scanning every single item in your cart one by one. It's flexible, sure, but it takes time. NumPy, on the other hand, performs one operation on the entire set of numbers all at once. It's like a futuristic scanner that gets all your items in a single go. And that difference is everything when you're dealing with massive data sets. So that brings us to the solution, to our high-performance hero. Let's talk about what NumPy actually is. So what is NumPy? At its heart, it's a core library for doing math in Python. But here's the kicker. Under the hood, it's not just Python. It's built to handle these huge arrays and matrices using super optimized operations written in the C language. And because C is so much closer to the metal, so to speak, it can run these calculations way, way faster. And how much faster are we talking? Well, this number kind of says it all. We are not talking about a tiny little improvement here. We're talking about a mind-blowing leap in performance. And this quote just drives the point home. These things called vectorized operations, which we'll see in just a minute, are the key. Instead of a slow, clunky Python loop, NumPy gives you something that can be up to 100 times faster. That's the difference between waiting a few seconds versus waiting for your whole lunch break. So, how in the world does NumPy achieve this incredible speed? Well, it all comes down to its secret weapon, a special kind of object called the array. Meet the n-dimensional array. It literally stands for n-dimensional array, and it is the absolute backbone of this entire library. Just think of it as a supercharged, highly efficient grid that can hold all your values, whether it's a simple list, a 2D table, or even a 3D block of data. And here is the secret to the ND array's magic. It uses what's called homogeneous data. That's just a fancy way of saying that every single thing inside the array has to be the same data type, so all numbers or all decimals. Now, Python lists are flexible. They can hold anything. But this strict rule allows NumPy to pack the data super tightly in memory and process it way more efficiently. It's a huge part of why it's so fast. And maybe the best part of all is that getting started is just so simple. You just import the library, you take a regular old Python list like this one, and you wrap it in the np.array function. That's it. Boom. You've just turned a slow list into a high-performance NumPy array. Okay, let's get to the really fun part. Now that we have these powerful arrays, what kind of super-powered math can we actually do with them? Well, NumPy comes with a massive built-in toolkit right out of the box. You can do math on every single element at once. You can run complex stats like mean or standard deviation in a heartbeat. You can handle advanced linear algebra, generate random numbers for simulations. Honestly, the list just keeps going. Just look at how clean this is. In regular Python, you'd have to write a loop or add everything up and then divide by the length. But here, you just create the array and call the .mean method. One simple, super readable command, and you've got your answer. It's just elegant. And this is that vectorization we were talking about earlier. Check it out. We make an array with numbers from 0 to 4, and then we just write a times 10. That's it. No for loop needed. NumPy just gets it. It understands we want to multiply every single element by 10, and it does it all in one lightning-fast operation. And it's not just for simple arithmetic either. NumPy can handle some seriously complex stuff. For instance, matrix multiplication, which is a cornerstone of linear algebra, is just a single function call, np. This makes incredibly powerful math suddenly very accessible.
Okay, so we've got speed and we've got power, but the last piece of the puzzle is understanding NumPy's true impact. Why does this one library matter so much in the grand scheme of things?
This right here is why. NumPy is the bedrock of the entire data science ecosystem in Python. All of these huge, essential libraries you see, pandas, scikit-learn, matplotlib, even deep learning libraries like TensorFlow, they are all built on top of NumPy. They all depend on its fast, efficient arrays to get their work done. Seriously, learning NumPy is like learning the alphabet before you try to write a novel. So let's just quickly recap the big ideas here. What do you need to remember? First, NumPy means speed. It blows past Python's normal limitations. Second, efficiency. It uses way less memory because of those specialized arrays. Third, power. You get a massive library of math functions for free. And most important, it's the foundation that the whole Python data science world is built on. And that leaves us with one final question to think about. Now that you know there's a tool out there that can make your calculations up to 100 times faster, what problems in your own work, in your own projects, what could you solve that much faster? Thanks for tuning in.